Hello, everyone. I'm David Segal, Director of Business Transformation for PTC Federal Aerospace and Defense Industry Vertical. And as part of LiveWorx 2020, we will present CBM Plus 4.0 presentation for digital transformation for maintenance and reliability. A couple of words about myself. I am leading business development for FA&D industry vertical at PTC, bringing my 20 years industry experience in engineering and manufacturing enterprise software solutions. And together with me today, Maddie Hawkins, Director of IoT Sales from Equitas Solutions. Maddie leads the company's expansion into IoT and augmented reality markets, where they have received several awards under her leadership. And with Maddie, we have Michael Hayes, who is Director of Lab Services at Equitas Solutions. And Michael brings 25 years of product development, system integration, technical instructions, and leadership experience to Equitas team. Particularly, Michael has expertise in IBM Smarter Solution products and in IBM Maximo. So we're glad to have Maddie and Michael supporting our PTC condition-based maintenance session today. Thank you for your support. And for today's session, we will divide our time equally. I will start with the condition-based maintenance solution overview, and its value proposition, business value KPIs, and some of the case studies. And Equitas team, Maddie and Michael, will present connected maintenance solution and their integrated ThingWorx solution with Maximo maintenance information system, but most importantly, their demonstration how that solution works. I would like to start with key takeaways, which is in fact the key value proposition subjects. And the first one is digital thread connectedness, which is in the core of condition-based maintenance solution that transforms time-based and usage-based maintenance into predictive and prescriptive maintenance. So connectedness is the actual and practical method that PTC technology enables, and I will speak about it quite a bit just right away after that. Another takeaway is the key promise of PTC CBM Plus solution is that application and integration of appropriate logistic processes, technologies, and knowledge-based capabilities to achieve the target availability, reliability, operational support, and cost optimization of systems, assets, components across their life cycle. So in short, it's digitalization and digital continuity across multiple logistics and service and repair systems and their integrations all together. And the third key takeaway, it's actually about connected maintenance, which is integrated with asset management system and maintenance information system, which is a foundation for automation and simplicity in service operations. So those three takeaways from this session. And I would like to start with a challenge. And the challenge for reliable sustainment and lifecycle management that I guess everyone understands, and we all experiencing it, but we would like to, in order to position our solution in the best way, we would like to outline what this challenge is. The subject of improving maintenance, reliability, quality, and service isn't a new subject. There are a multitude of regulations, practices, systems, and solutions that have been in use for quite a while. It becomes really challenging to navigate between so many different approaches. It becomes challenging for typical maintenance and service program to practically plan what needs to be implemented, how, and from what to start. From one aspect, organizations need to consider performance-based logistics, which was the US DoD strategy since 1998 till 2014, and that strategy has been implemented widely across US military and DoD network. And PBL SLA, service level agreements for assets and equipment uptime and performance, were and still are the key contractual measurement with 3 levels of service. Another aspect is existing condition-based maintenance and reliability-centered maintenance processes and practices, which included into logistics and material readiness and push through supply chain system. So it's a very wide area of different practices for immediate, deferred, scheduled, and preventative maintenance. It's actually what builds this preventative maintenance practices. In addition to this, almost every organization has some sort of asset management system, which could be enterprise asset management system, vendor-based or legacy-based homegrown systems, or some sort of service part management systems with in-service part data, inventory management systems. And the question is, how those systems really contribute to condition-based maintenance? Do they need to contribute to condition-based maintenance? Another area is that organizations implement health and usage monitoring systems, which become very popular, and assets performance management system. And again, the question is how those systems really connected and contributing to condition-based maintenance practice. Key subjects for reliable sustainment, such as operational availability, mission readiness and reliability, logistics response time, total life cycle cost per unit of usage, overall cost per unit of usage, and logistic footprint, they have been outlined in the DoD regulations in 2005. Then it has been revised in 2009 for cost rationale, but still in general, the challenge of complexity in implementing condition-based maintenance remains the same. Then in July 2019, DoD introduced digital engineering strategy that brought digital aspects to condition-based maintenance with digital infrastructure, which could be a cloud systems with digital data, with models extensibility, with innovation in augmented and mixed reality. And this was actually influenced CBM policy in such way that DoD issued recently Instruction 4151 for CBM Plus for material maintenance. It's, in fact, it's complete revision for the previously published guidance. I outlined this journey to make emphasis that PTC technology for digital and physical conversion is perfectly positioned to address this evolution of objectives for reliable sustainment. PTC experience being a leading technology company in Industry 4.0 domain with portfolio of innovative tools which have been used in many defense programs and within aviation industry, commercial aviation industry, sets us as a good partner in digital transformation journey for condition-based maintenance. That's the our objective presenting this solution and promoting this solution. Can we name one aspect that would explain why so many great rules and good solutions didn't bring the desired outcome for reliable sustainment, maintenance, and service in both in defense and military domain as well as in MRO and commercial aviation domain? And that subject is time-based or usage-based maintenance aspect. That if we see all the existing practices, they are all based on time on your usage, whether it's time-based maintenance, including all the scheduled, planned, and periodic maintenance, and obviously repair and corrective maintenance. So in fact, all practices, whether it's PBL, quality, safety, they're all today based on time or usage, which bring us to the fact that preventative maintenance which is based on time and usage criteria, leads us to the problem of over-maintaining. It is hard to obtain metrics for the value of preventative maintenance, but we use insight from two analyst firms who assess statistics from actually different industries, different groups, on how preventative maintenance performs, what its value. And it shows that 40% of scheduled maintenance costs are spent on assets with negligible effect on uptime failure, which it means that actually 40% of cases in 40% of cases, scheduled maintenance has no impact on assets failures, in fact. Or another metric, 30% of maintenance activities are carried out too frequently. And we all know that in order to save some money, that organizations look into the frequency of the maintenance activities, and it's always a risk to reduce this frequency. And finally, we can see that about 18% of assets, in fact, have an age-related failure problem, and more than 80% of assets, in fact, their failure appears random, besides all the effort for preventative maintenance. So what really we can bring to innovate and modernize condition-based maintenance, having the complexity of multitude solutions and enormous investments over years that have been done in this domain. PTC technology that enables digital twin and digital thread connectedness is the right approach. In fact, if I would like to leave you with one word out of my portion of this presentation, I would use the word connectedness, which is, in fact, this is my key takeaway number one. So the foundation of connectedness is Industrial Internet of Things. PTC Industrial Internet of Things platform, ThingWorx, enables automation and connectivity between assets, machines, devices, sensors, servers, IT servers, and different data sources. It can enable and address very broad scope of condition-based maintenance use cases, starting with assets health and performance monitoring with real-time alert and fault identification, with maintenance planning and optimization, with asset tracking, with maintenance production execution, using PTC augmented reality as technology for digital assembly and maintenance instruction, and also using real-time production monitoring dashboards. We can incorporate and connect different use cases from supply chain and logistics using spare part management or service part management systems, with inventory optimization, also including serialized parts. Use cases from environmental health and safety procedures can be automated and connected using augmented reality technology. Quality and test use cases for failure reporting, corrective and preventative actions, procedures could be included into this condition-based maintenance framework as well. And finally, from engineering perspective, we can include engineering and manufacturing data, different bill of materials for retrofit, change management, even including reverse engineering for additive manufacturing parts as input and output from condition-based maintenance framework. I will not go over all those use cases in these presentations. Some of the case studies later in my presentation will showcase some of those use cases. And certainly organizations today are addressing those use cases already with their own processes, different legacy systems, and their own best practices. All what ThingWorx Internet of Things connectedness brings is the ability to aggregate, synthesize, and orchestrate maintenance, service, and logistic data in order to make the move from time and usage-based maintenance to the actual real predictive and condition-based maintenance. And that's, again, the goal of presenting this solution. So PTC technology with connectedness enable condition-based maintenance in the way how it is defined as a maintenance performed based on evidence of need, meaning the maintenance performed only when it's needed based on different conditions. So how PTC CBM Plus 4.0 solution enables condition and preventative and predictive maintenance through that connectedness? First, the solution integrates existing preventative maintenance capabilities, all the reliability center maintenance, all methods, all this logistics, material readiness, and PBL methods, integrates them with real-time operational data and different trends and anomalies captured through the real-time sensors, using condition monitoring, using assets and tools health monitoring, using prognostic fault and failure prediction, and actually applying data analytics and artificial intelligence for building prescriptive maintenance dashboards and decision-making workflows and root cause analysis procedures. That's one aspect of integration. Another aspect is interoperability, which is a unique ability of ThingWorx IoT platform not only integrate, but also enable interoperability between different systems like maintenance information systems and different asset management system, quality and risk management system, depot, repair, stock, warehouse, procurement, order, ERP systems, and also engineering systems. So it's not just integration, which in many cases just static data exchanges between systems, but interoperability, in fact, what makes that data actionable, dynamic, and operational. So a solution building blocks architecture, I call this diagram architecture, is a good illustration for overall PTC CBM Plus solution framework. So let us start from the left lower corner of this slide. So you can see different data sources and enterprise systems of record. CBM Plus solution is enterprise system of record agnostic, meaning you can include and integrate any ERP system, any legacy master data management system, or any maintenance information system. In fact, the second portion of this presentation with Aquitas solution, they will show how IoT platform will be connected to Maximo maintenance information system. And even though PTC has its own product lifecycle management system or service part management system, which are systems of record, I mark those technologies as complementary technology because they are not essential for this condition-based maintenance framework. What is essential is what's in foundation of this diagram. It's ThingWorx IoT platform that aggregates and synthesizes all the data coming from enterprise systems of record, as well as real-time data coming from sensors from assets deployed on the field, or different sensors deployed in the manufacturing or depot facilities. And this data get synthesized, orchestrated, put into analytics engine and machine learning for trending analytics, for troubleshooting analytics and assets performance over time analytics, which can be captured as augmented reality service and pushed through augmented reality to the maintainers in the field, or can be presented as part of condition monitoring dashboards to those who are in the depot monitoring failure prediction and what-if analysis, and actually orchestrating all these decision support workflows for condition maintenance. So that's essentially the overview of the solution. This chart is showing the overall solution, but the question still remains how to implement it and from what to start. The CBM Plus solution is a modular and open framework, which is actually differentiates PTC and our solution from any other vendor solution today in the market. So the solution can be implemented according to organizational priorities, goals, and abilities. For instance, some organizations can decide that they would like to implement this CBM Plus solution from augmented reality frontline worker and technician point of view, and from those type of use cases. Some organizations can decide that they would like to capture real-time Internet of Things sensor data, aggregate this data, and present those dashboards in order to monitor health of their assets and devices, and provide some root cause analysis of different failures and predict those failures right away, without, for instance, aggregating or integrating this data into the systems of records. Some organizations would actually start in reverse order. They would first see how their existing maintenance information systems, ERP systems, can be integrated into Internet of Things platform, how that digital data can enrich some sensor data from the field or from the repair workshop, and see how that can affect condition-based maintenance from this point of view. And finally, some organizations, they would position their legacy data systems first and see how existing procedures for preventative maintenance that they perform today can be enhanced with some of the connectivity to assets. So our solution framework supports any point of view of implementation or any use cases that actually I presented in a couple of slides earlier. As an illustration for this integrated scenario, fully integrated scenario through several systems, I would like to bring this example of on-asset maintenance procedure that we actually propose as a baseline for many of our customers, and in some of the case studies you will see, in fact, that they follow more or less the same approach. So when it starts from monitoring assets health, that can be done with ThingWorx platform. You can see I include the logo of ThingWorx platform. Then investigate failure condition based on different troubleshooting analysis and different trends that can be analyzed with ThingWorx analytics and reliability models. So those models can show very clear failure condition according to which alerts can be delivered through the systems. Then those alerts can be pushed into the maintenance information system in order to schedule maintenance activity. So that can be done through any maintenance information system. Then plan for parts availability for this maintenance activity can be done using PTC service part management system and connected service part management system, Servigistics. I put the logo of this product here as well. Then we use augmented reality empowered with Internet of Things feeds for execution of the maintenance when the procedure how to execute the maintenance is guided by technology. And also using augmented reality, we can actually digitalize work instructions and work procedures for part replacement and actual service and maintenance procedures. Finally, connectivity to engineering systems will enable update for as maintained, as serialized as service bombs. And finally, all this consumption rates, failure rates analysis, corrective and preventative actions can be used in the PLM system. So that's a typical integration scenario driven by on-asset maintenance use case. And you see that scenario can be scaled up across supply chain when different touch points with the supply chain systems can be done, for instance, for the spare part availability, and that on-asset maintenance procedure can be implemented in different portion across the supply chain. So unfortunately, in this virtual pre-recorded event, I can't stop for questions. So I will go right away to speak about condition-based maintenance business values, key performance indicators, and will summarize a couple of case studies from customers who implemented and used our solution. So I start with several metrics that we captured from pilot projects and production projects from our customers who used condition-based monitoring for predictive maintenance using Internet of Things platform ThingWorx. And there are two aspects of those key performance indicator. One, I would call them generic, and then more practical performance-based logistics KPIs, which are outlined in all their policy and regulations. So we can see that overall condition-based maintenance deployment would lower the cost for maintenance procedures more than 40%, improving productivity, improving business processes. Most importantly, I just want to highlight this 91% accuracy in predicting alarms 24 hours in advance when failure actually happens. I will have one case study that actually supports this metric. Another interesting metric is 35% reduction in unnecessary parts exchanges. I guess every service organization struggle from the aspect of unnecessary parts exchanges and orders and inventory, although they even implement inventory optimization procedures. And by also implementing this inventory optimization procedure, they can gain even up to 20% additional savings. From PBL KPIs, look, it's quite remarkable what we have been reported from some of the pilot projects that we performed with our technology, like 20% increase in first-time fix rate, or 10% assets uptime increase for operational availability, or more than 50% reduction in mean time to repair, which is quite a clear metric for the success of this type of solution. So which means it's almost no-brainer how to implement this IoT technology for condition-based maintenance. And as a couple of examples for case studies, I would like to bring Lufthansa Technik as a large MRO organization that implements their digital transformation with PTC Windchill, PLM system, and ThingWorx IoT system. For Lufthansa Technik, the seamless integration between Windchill and ThingWorx will enable new levels of collaboration both internally and across their supply chain. Windchill PLM will serve as the engineering backbone to enable R&D and manufacturing to work concurrently, which is by itself quite a big challenge to make engineering and manufacturing work concurrently, and also through the secure data repository, intellectual property access, and that R&D environment will be integrated or interoperated with the ThingWorx and Kepware-based IoT condition-based system that created a fully connected shop floor for real-time assets health monitoring and predictive maintenance to improve quality and speed of maintenance, repair, and overhaul services for Lufthansa. So this is more generic, and we will be glad to provide more details for any case studies, so please feel free to reach out with those questions. Another example coming from our demonstration project that we did for OSHKOSH Defense and presented on last year LiveWorx, where AR-enabled condition-based maintenance procedure was created for OSHKOSH GLTV. First, we created a scenario for mission readiness post and pre-mission inspections for a warfighter and maintainer in the field, how to actually assess different conditions for the field maintenance and service for the vehicle, and then how to scale up this information for connected fleet management for service operation manager or quality and reliability manager, when all different trending and troubleshooting analysis and dashboards can be created. This information, in fact, can feed different other scenarios, like using generative design for reverse engineering and for immediate parts additive manufacturing in the field, validating those additive manufacturing parts through their design review, and then actually enable work instructions to replace those temporary additive manufactured parts for replacements in the field. So that's demonstration is available and will be posted. I just want to bring some illustration from the augmented reality view on handheld device, when the vehicle operational information presented as one summary, one summary with the conclusion whether it's mission capable or not mission capable. And finally, the value that OSHKOSH Defense and US Army could actually use and derive from using condition-based maintenance and ThingWorx for asset self-reporting and sensor-based condition data is very important, and we can see that it can be scaled to the not just for one vehicle but for the entire fleet. So it may drive this usage-driven readiness decision based on real condition and reducing vehicle downtime and parts cost, and enhanced mission planning and actual predictive maintenance instead of preventative and scheduled maintenance. Another case study coming from a UAV manufacturer for whom we did a pilot project for assets health monitoring, for engine health monitoring in the UAV, where sensor data was captured and gathered from equipment on board in various modes: in-flight mission, pre-flight mission, and readiness takeoffs and landings. All this data was not obviously streamed from this UAV. All the log files were stored on board and then downloaded into ThingWorx based CBM system. And ThingWorx Analytics analyzed and created reliability models for 500 flights with 18 critical failures. And the goal was to analyze those failures and come up with the model that would predict and raise alerts and alarms 24 hours prior that actual equipment failure will happen. So that's actual predictive maintenance objective. I included here a screenshot for a ThingWorx dashboard for the engine health monitoring that shows that different engine anomalies have been recorded in the system, and then trend analysis and assets performance over time was analyzed by ThingWorx, and finally it gets with the 91%, over 90% accuracy on failure prediction 24 hours prior that actual failure of that engine would happen. And that's how you can see this happening on the dashboard. And obviously this is kind of internal dashboard that used by the mission commander, but certainly this data can be utilized in different user experiences as well. And a similar project, demonstration project we performed for General Atomics, which again was showcased in our previous LiveWorx session, and same principle from assets inspection, assets overview, condition assessment, inspection, technical support, procedures through augmented reality, then readiness assessment, and return to service. So that's another use case. I will conclude here my portion of the presentation for Condition-Based Maintenance Plus 4.0 PTC solution. My colleagues from Aquitas will present connected maintenance use case with seamless integration between ThingWorx IoT platform and IBM Maximo maintenance information system. So I would pass my presentation to Maddie Hawkins. So Maddie, please continue.
All right, everyone, we're going to really jump in since we've got a lot of information to cover in a short amount of time. I'm Maddie Hawkins, Director of IoT Sales at Aquitas Solutions, and you're also going to hear from my colleague, Michael Hayes, who is our Director of Development during this presentation. So what I want to focus on today is really how we've leveraged ThingWorx to build a solution we call Connected Maintenance, which uses a two-way integration between ThingWorx and your maintenance system to drive action. I want to quickly give you all some background on Aquitas as a company, and then we're going to touch on a couple of fundamental principles within maintenance that are just critical in understanding how to be successful with this type of implementation and where the value is with IoT. Then we'll look at a quick overview of our integrated solution before jumping into some use cases and demonstrations, and then we'll wrap up. So for anyone not familiar with Aquitas yet, we were founded in 2006. We're a service-disabled, veteran-owned small business based out of Atlanta, Georgia, but our employees are all over the country. For example, I'm located up in Virginia, if there's any fellow Virginians listening. But our background and expertise really lies in the maintenance and asset management space. From the beginning, our core business has been focused around IBM's Maximo Asset Management solution, and our consultants average over 14 years of experience in that space. But around 2012, when Michael came on board, and came from IBM, where he'd been working on the original Smarter Buildings, Smarter Cities teams, we launched what we called our Smarter Solutions, which were really our earliest visions of what IoT could look like. It was maybe a bit early to market, but we kept that IoT vision in our strategy and continued to evaluate how we could meet the needs of our Maximo customers who wanted to connect all of these external data sources into Maximo. So in 2017, we officially partnered with PTC, and then in 2018 launched our integrated connected maintenance solution for Maximo. Since then, this side of our business has just continued to grow and expand as we have quickly moved into the augmented reality space and make the solution available for customers using other maintenance solutions outside of just Maximo. Our strategic partnerships are also what have enabled us to continue to grow, working with the best-in-class technology from globally recognized companies like IBM and PTC. And then again, we also recently engaged in a partnership with Arrow Electronics for our many customers who need help with sensor procurement and installation because they have a significant amount of legacy equipment that needs to be connected. And also, since launching our connected maintenance solution in 2018, it's received a tremendous amount of industry recognition, most recently placing silver for Maintenance Solution Product of the Year from Plant Engineering Magazine, which we are still very excited about. Let's go ahead and dive into the fundamentals of IoT and maintenance. The first thing we need to do is forget the old idea that failure patterns follow a bathtub curve with a higher failure rate in the beginning or end of the asset life. Because the reality is that 82% of all failures are in fact random, which leaves maintenance teams constantly left in this reactive state trying to manage these unexpected failures. So what does this really mean to maintenance? The reality is that this constant need to respond to these random failures makes it really difficult for maintenance organizations to keep up with even just your basic planned work. So unfortunately, right now, most of the customers we talk to really fall into this reactive category on the right. And the question then becomes, how can IoT help us move up the curve to eventually become predictive? And first, we need to understand a couple of basic maintenance truths. The first one being the most efficient maintenance is maintenance you don't have to do. Well, you may be sitting there saying, that's great, Maddie, but how do I maintain the health of my assets without actually doing maintenance? And the reality is that within maintenance, there are many cases in which we're over-maintaining our assets. Not to mention, every time we touch an asset, we introduce the risk for failure. So first, we need to start by looking at the maintenance strategy on our assets and evaluating the effectiveness of that strategy. And it starts with answering these four basic questions. What time or meter-based PMs are being executed? How much time is being spent completing those PMs? What is the failure rate on those assets despite these PMs being done? And what's the cost of failure or unplanned downtime on those assets? And then we can begin to understand where the opportunity is to eliminate some of these non-value add PM activities. And I challenge you to ask yourself, what would that mean to your organization if you could reduce your preventive maintenance activities by 50%? How many labor hours would that actually free up for you? Second truth is that while all assets will fail, not all asset failures are equal. So one of the most challenging and actually daunting tasks in implementing an IoT solution, in my opinion, is figuring out where to start. And understanding where you can find the greatest return on investment is critical for both the short and long-term success of the project. Those high value, high ROI opportunities within maintenance, we really focus in on two key asset categories: low cost, low impact, or high cost, high impact assets. So low cost, low impact, these are the assets that require frequent manual intervention, inspection, or other kind of interaction. And while these asset failures may not be costly or have a critical impact on operations, they typically happen more frequently. So we call these more of the death by paper cut type scenarios. And to give you an example, we'll take a look at a steam trap failure, for example. We estimate that a steam trap failure cost averages about $4,500, and someone typically has hundreds of steam traps. So if we, in this example, estimate that just 50 failures happen in a year on steam traps, that would equate to an average of about $225,000 in failure costs on those steam traps. This is a perfect example of a very simple use case that provides fast time to value and ROI on one of those low cost, low impact asset types. Now, in looking at high cost, high impact assets, these are the assets that do have a catastrophic impact on operations, quality, availability, or cost if a failure occurs. These failures might be less frequent. It could be that this asset only fails once per year, or maybe it's once every 3 years or so. But when it does, it's catastrophic. So in this example of a separator motor on a critical piece of equipment for one of our customers, a single failure is estimated to cost $125,000. So in this example, even if it failed one time this year, it's obvious why monitoring these high impact assets is critical, even without a failure. But really the key takeaway here is that there's huge opportunity in both asset types when you look at your strategy and how you roll out an IoT solution like this. So to bring it back to the PF curve, eliminating our non-value add PM activities and monitoring those high value, high ROI assets provide a clear path from being reactive to proactive while providing the baseline and foundation and data capture necessary to eventually truly become predictive. All right, so now we're going to go ahead and switch gears and take a look at what the actual solution looks like. I'm going to go ahead and walk you through what a generic, typical connected maintenance framework looks like for our Maximo customers to give you a bird's eye view. And again, remember, in this case, we're going to use Maximo, but it could be any maintenance system. So starting out on the left here, we have all of our critical assets and different data sources, whether it be sensors, SCADA system, a historian, other legacy platforms. And on the right here, we've got Maximo or your other maintenance system. And the question has always been, and again, it's not new, but how do we effectively get the data from our critical assets and our data sources over into Maximo to create the right action to address any problems? And the way we do that is ThingWorx. First, we're able to aggregate all of those data silos into ThingWorx, and then we're able to go through that anomaly detection, rule creation, and analytics to be able to identify when something is not just unique but problematic, and then kick off automatically through the two-way integration to Maximo the correct action for maintenance to be dispatched and address the problem. Now, one of the most important factors in the success of that integration, though, is eliminating false positives or duplicates. And in fact, it's one of the most commonly asked questions that we get when we start going into these implementation conversations. We do this by creating what we call recipes for failure, which are essentially simple or complex rule parameters set in ThingWorx meant to identify a failure before or immediately when it occurs to be able to trigger the appropriate action in your maintenance system. And really the starting point is asking these three basic questions. What problem are you trying to address? What asset data is available? And what's the action that needs to occur? But also through our integration with connected maintenance, we're also including Maximo data or your maintenance data in your recipes to check things like, is this asset currently active? Is there currently an open work order on the asset? These checks are really critical in filtering out duplicates or false positives. And I'll give you an example of both a simple and complex recipe. A simple recipe may look at one condition with a basic threshold. Like in this case, we have 2 recipe levels. If the temperature drops more than 2 times in an hour, we want to create a service request. But if it's more than 4 times, we want to create a work order because that indicates to us that it's more urgent. On the complex side, a complex recipe may look at several condition variables or systems, like if RPM drops and current increases in this time period, kick off the service request. But if it happens 5 times in 2 hours, again, we know it's more urgent and we need to then generate a work order. With that, let's go ahead and talk about some maintenance-specific use cases and demos. And I will ask you to bear with us through this section. We did have some technical and scheduling challenges, so the demos were recorded live, again, by my colleague, Michael Hayes, but they will be played as videos as part of the presentation. So let's go ahead and jump in. Starting out with the most critical use case and core functionality of our connected maintenance solution is really the ability to drive these automated actions in your maintenance system. In the demos we're going to be showing, we're going to be using Maximo, but it could be another system. So what Michael's going to show you is how we can monitor asset conditions and trigger a work order in Maximo in real time based on our recipe for failure, and include other value add automation options like including a job or safety plan, or a failure code, or inventory associated, or labor resources needed. So let's go ahead and take a look at what that looks like.
We're going to go into these a little bit later, but let's just go right to Maximo work orders. And as you can see here, currently this particular motor does not have any work orders. And what you're going to be looking at is, this is a real live, see, here's my thumb. Woo-hoo. We're going to do thumbs up there. And we're going to add a little bit of augmented reality here, but this is using the ThingWorx platform. I'm using a, you can see here, this is a iPad. And this is a demonstration motor that I have for this. Just to kind of give you a little bit for the demonstration purposes, what you see here is this is a motor that may represent a variable speed drive, or it could just even be a single drive motor. I also have some plungers over here that are going to put some load on the motor so that we can simulate a specific condition. And this is a Allen Bradley PLC controller that we have directly connected to the ThingWorx platform, and I'm getting real-time data. So this data that you're seeing up here in these bubbles is real-time, and we're going to have a condition. So let me go ahead at this point. Now this may be a little bit loud, hopefully not too much, but I only run it for a few seconds, and we should be able to cause a work order to be generated in Maximo. So let me go ahead and get that started. And I am using my device here, another iPad actually, and I'm going to go ahead and start the motor. And you will see the numbers changing in the real-time data up here. Okay, and I'm going to go to level 1. And go to level 2. Okay. Now, what I'm going to do too is I'm going to turn this on, turn it off, turn it on and off for certain conditions. Maybe it's got an on and off condition. And let's do it a few more times. And what I'm going to do as well is I'm going to turn these on and off really quick. Okay, and the reason why I wanted to do that was just to show you that as part of our connected maintenance solution is that not only are we looking at the motor, but I just caused this particular, in this case, it's a danger, a current has reached its upper threshold. Well, one of the things that I have been doing integrations for quite a while, and this really, a lot of this isn't necessarily new, it's just more of how hard it is to get the information into Maximo and then how it's used in Maximo. But the biggest thing is that every time an alarm occurs in your system on the sensors and on your controls area, we don't want to create a work order, because you would have sometimes that threshold goes up and down, it bounces, it goes above, it comes back down, it goes above, and every time, or it may be that it's constantly alarming. We don't want to create a work order for every time that something alarms, because then we'd get a bunch of work orders that's all the same. So as part of that, the reason why I wanted to show you that I did it multiple times is because it only creates a single work order. That's part of our solution, is that it goes and does a bunch of checks and says, first of all, is this asset even active? Because if it's not active, or if it's currently being worked on, then the reason why we're getting that alarm is that where they're possibly doing some stress tests on this particular motor. So as part of the solution that we have with Maximo, is that we using the ThingWorx platform, we're going to Maximo, getting data about the asset, getting work order information, and saying only create a work order if we are in a real live running state, as we are in this particular example. Now let me go ahead and go to full screen here so we can see more. But from here, we just created this work order. Let's go ahead and double click on it. It takes you right over to Maximo. And here's that particular work order. Now, one of the great things about this as well is with the integration that we created, here is the ThingWorx alert name. And what we've done is being able to, you built this, spent the time building this a recipe. Then if you know what is, what this alarm or what causes this alarm, then you can go ahead and create with it a job plan saying, well, I know exactly anytime we get a danger high current, then this is the job plan that I want to associate with that work order. You don't have to go out and try to figure out what job plan it is. You don't have to take that manual effort to do that. You can assign a job plan with that specific alarm. You can assign a failure class and a problem code, or you can do it manually. Either way, it gives you that flexibility. And in this case, I did one. I put in the failure code, but not the problem, allowing the user to enter that. But again, when it entered these, when these job plans were created as part of the integration, you look over in the plans, and sure enough, here are all of the tasks that you need to do to take a look at that motor and find out why are we having a high current condition. But also, we're adding a little bit more information too. Let me go ahead and go to the long description. Now, I'm going to make this bigger so you can see it better. But what is allowing you to do as well is getting some snapshot information about the environment and what was going on with in this particular case, the motor at the time that the alert took place. And one of the first things you may notice here is that I have, well, here's your condition. It gives you an exact. So we were definitely pulling, our current was definitely way above our threshold. We also connect directly into, you can do this as a historian and look at stuff, or looking within the ThingWorx platform as well to look at history and say, well, look, this thing in this case, and this is the first demo I've done it today, but it's happened 0 times in the past 2 hours. So this means this is the first time that this has occurred. But we can go back in history and it tells you something. It says, well, this has happened 5 times in the past 2 hours. And these are 2 configurable parameters you can put in there. And this can even be part of your rules. You can say, hey, you know what? Only email me or only send me a text message if it happens once an hour. But if this thing is starting to get past this threshold 3 times in an hour or 2 hours or 24 hours, then I want you to generate a work order. What we're trying to avoid here is have you have better control over eliminating false positives. Because I've been doing this a long time, guys, and many of you have as well. Sometimes things just occasionally will just either during startup that certain values will go out of normal running operating parameters or thresholds. And we don't want to be notified or create work orders when that happens. So this allows you to have that ability. It also takes you a snapshot of looking at this and seeing additional data. What was the motor? What were other parameters going on? But you're not just limited to this. You can actually set it up so we can look at related asset data and say that, well, if the pump is doing this, what is the valve position is downstream. It allows you to get more information. And again, it just helps to determine what is the root cause of a specific situation.
The next use case we're going to discuss is automated and advanced meter readings. A frequent question that we are asked from our Maximo customers is, how do I get data from my historian into Maximo to populate meters? And because of the ease of integration to external systems, we built an application using ThingWorx to more effectively connect to and manage meter readings. It's so easy, in fact, that when we look at overall level of effort required to build a custom integration From a historian into Maximo, for example, the cost can easily reach over 3 times a single ThingWorx license with only a fraction of the functionality. So ThingWorx really significantly simplifies the process required for setting up, tagging, and automating meter readings that may have previously just been taken manually. Plus, we can also see that historical reading data and, of course, generate a preventive maintenance work order based on meter rule parameters when needed. So let's go ahead and take a look.
Who are currently using Maximo meters today, most people are going in, taking measurements, writing them down on a piece of paper or a clipboard, and then having to go in and enter in meter readings in Maximo. And a lot of times, that's one of the reasons why that people don't use meters as much as they could, is because of that manual process. Well, we made that a whole lot easier in the aspect that this particular table here is reading the meter table over in Maximo. So let me just show you really quick. Go over here to the asset in Maximo and enter. Here's my demo motor. Go to, not safety, but go to meters. But here are the meters. And you'll see some are active, some are not active. But these are the exact same meters that you see. So if I look at temperature, for example, you'll see that when we just ran this, well, actually it's been running all day, that the last time that it ran, I had this going twice a day. It's at 7 a.m. and 7 p.m. that it updates this meter reading. That it was done just recently because I'll show you a few minutes ago, I pressed the button to force it. But we're getting meter readings automatically from the ThingWorx platform. And how we do that is here. What you do is in here, you go to Maximo Meters. It will automatically populate. It goes over, grabs the meter readings from Maximo, shows them up here, and then once they're here, this is how easy it is to associate a meter to a Maximo meter reading. And that is that you have this reading. Here is a list of all of your tags and your tag properties. All you need to do is pick it. So in this case, I did suction pressure for this in pressure. Hit update and turn this on. You're done. It will begin immediately, go in and start, based upon your schedule, will begin to do meter readings in Maximo.
Now we're going to wrap up by looking at a couple of examples of use cases that digitize and automate manual processes and maintenance, starting with one around oil analysis. In this example, we had a customer who was sending oil samples from their gearboxes out to a third party for testing, and they'd receive a CSV file back with the results indicating which samples were clean, dirty, contaminated, whatever the result was. And then someone had to physically take the time to analyze that report and create the corresponding work order as needed. So what you're going to see here is how we built in the intelligence in ThingWorx to easily upload the file and automatically kick off the correct work order, which really can cut the time required to analyze and create the corresponding actions from these reports, potentially from hours down to a matter of seconds, as you're about to see.
So what we did is we have a CSV file. We took their files. So we would go in, and I have a sample of one of their files here. I got it.
Yeah.
I got it. So here's the file, and then I upload it. We do an analysis, and here's that file. So what it's doing is it brings it in just like a spreadsheet, an Excel spreadsheet. And then, but now here's the problem code, and this is exactly what they would have to do manually. They'd have to say, oh, this one's dirty, this one's normal. This one has somewhere, and maybe this has degradation. But what we've done is that being able to do this oil analysis, and you hit it again, at this point in time, it would go through, scan it, and would create a work order in Maximo based upon this condition.
All right, the last example we're going to share also falls under this category of digitizing and automating a manual process, and it's around what we call round sheets, or some people call them field sheets. But regardless of what you call them, most maintenance organizations do still use some form of paper round sheet that requires their technicians on a scheduled basis, whether it be daily or weekly, to go around and check some type of condition and record the value. It's an extremely inefficient process that not only requires unnecessary labor hours, but most of the time when we ask what happens to those papers, do you know what the answer is? Nothing. So we leveraged mashups and ThingWorx to basically just duplicate what paper round sheets looked like to enable the immediate data input that can trigger alerts and warnings in real time, and then significantly improve the accuracy of recorded data. And of course, then we can also start using that historical recorded data to become more predictive. So let's go ahead and see what round sheets can look like in ThingWorx.
What about assets that are not monitored? What about assets that are not censored, or they're in remote areas where we can't get to them very easily? And so what about this manual data that we're doing, or what we call as field sheets or round sheets? What about that data? Is there a way we can consume that? And of course, the answer is absolutely. So let me give you an example of a customer that we did on this as well. This is more from an energy company. And in this energy company, we created these field sheets specifically for this was a energy company that had cooling, a lot of what they call cooling ponds, and they had tons and tons of measurements that they had to take, everything from pump cleanouts to piezometers, that they general inspections. They looked at their sump pumps. So they had different checklists that they wanted to do. So let me kind of give you an example of one. What we did is being able to use, now they're just using their, they could use their mobile device, or in this case, they use some tablets to be able to see this information. And it looks pretty simple, but we wanted it pretty simple because, again, you're going to be on a mobile device. But you can see this is one of these facilities, and this is one of these cooling ponds. And I can scroll in here, and you can see here's one of the pumps, the plant pumps, but they have all these different measurements. They have tanks that are over here. These are tanks that are here that they need to do measurements on. They also have these little retention ponds as well. But the main thing is that these were things that were remote.
Well, and also, Michael, let me add one thing here, because, it's great to see that, we can do these types of readings and ThingWorx by creating a mashup, but really the problem this solved for this customer was that they were actually doing these manual readings on paper. So their technicians were going out every single day with a pen and paper recording these readings. And then when they were done that day, they would hand in these papers with all of these readings that many times they were also getting incorrect readings that they were writing down, that someone else would then look at, try to analyze, enter into a completely different legacy system, then perform analytics on it through a completely different system. And if an issue is identified, they would then have a third person manually enter in a work order into ThingWorx or into Maximo. And so by doing it this way and being able to just directly enter the information into ThingWorx for the analytics and the recipe for failure, we can trigger that work automatically and completely eliminate. We can automate that data capture and action process so much easier than what they had before. And that's the goal, with all of these, is to automate processes where we can and be able to, do things more effectively and efficiently leveraging all this new technology.
Yeah, appreciate it, Maddie. Thank you. Absolutely. And one thing I wanted to add to that too is again, just going through and enter this data here, is that when you enter this data in through a mobile device of this nature, it goes in and it is treated in ThingWorx as if it was a sensor. Just as Maddie said, now that data is in there, you can apply it to anything.
So hopefully those 4 examples gave you some ideas of real use cases that can provide value and transform the way you fundamentally operate. So I wanted to close with this quote from one of our connected maintenance customers. It says, "For us, simplicity has come to mean a single managed source for all of our monitored IoT reliability activities. And for us, that source is ThingWorx." This digital transformation revolution that's currently taking place means that the market has become flooded with new sensors, IoT solutions, and cloud applications, many of which have similar alerting and dashboarding capabilities. In fact, sometimes it's hard for me to keep track of all of them and what has what capabilities. But the challenge, though, is no one wants to have to log into 5 or 10 or 15 different platforms to see information or see alerts on their critical assets. So ThingWorx helps us bring all of this information into one place and have alerts from the various sources in one place. And then through connected maintenance, your maintenance team will be able to react to problems in real time with the right information. If you have any questions or would like to discuss any of the topics from today's presentation, please feel free to reach out to me directly. My contact information is on the screen. I really appreciate your time today, and we invite all of you to join us in building a smart, reliable, and connected future together.